Hey all, welcome back to the lab. In this video, we're going to be talking about C# errors versus exceptions, really focused on some performance benchmarks. So I've been on an error over exceptions kick the past few months, and I've previously showed that TypeScript exceptions are 300 times slower than errors. And so here we're going to do the same thing with C# and see what our results are. So first let's talk about the benchmark setup. So we'll be comparing a few common scenarios of error passing using benchmark.net for benchmarking. So we'll be looking at throwing exceptions, creating exceptions, which is different, we're just creating the exceptions but not throwing them, result types, and then string types. In each scenario, we're going to be creating a GUID string to simulate a random error message, and then we'll be constructing the wrapper if applicable. Like obviously a string doesn't need a wrapper, a GUID can already be turned into a string. And then we'll be doing this 1,000 times to get a decent average. Now, a quick caveat here is that all benchmarks have asterisks, and these are contrived examples, as we'll walk through at the end of this post. And so to truly understand the impact on your system of choosing, one of these options, you really have to benchmark your own system. But for brevity, we're just using contrived examples here. Okay, so here are the benchmark results, and it looks like this is probably too small to read here in the video. So I've also put this here in just plain text so you can look at it. And so this is, the standard output of benchmark.net. We've got our throwing exceptions case, our creating exceptions case, our result type case, and our string type case. And so first, let's just start off with the time. And so we can see that throwing exceptions is by far the slowest with 4,800 microseconds. And then we can see that our creating exceptions, creating results, and string types are all about the same speed, right around 340 microseconds, each of which is about 14 times faster than actually throwing the exceptions. And we can tell because this is just creating a GUID and this is basically the same cost as results and exceptions, we can basically say that the majority of the time in this benchmark is spent creating the GUID versus actually constructing the wrapper. Now, if we go over to look at our allocations, we can see that throwing the exception is by far the most expensive in terms of memory. Creating an exception and not throwing it is about 50% less than throwing the exception. Creating our results is about 66% less, and then GUID is just a bit less than creating results. Okay, so now some highlights from these results. So first thing I want to highlight is that the result types are pretty efficient. Result types don't seem to add much time or memory overhead, which makes them a suitable replacement if you want more ergonomic type-safe representations of errors as values. A lot of times I see people saying that they don't want to add results because it adds too much overhead, but as we see here, it's just about as fast, and the added memory is about 20% extra versus the raw GUID, and so for better ergonomics, better type safety, that's usually a pretty good trade-off. The next thing to call out is that creating exceptions isn't slow, but throwing them is. So I'd expected creating exceptions to be nearly as slow as throwing them, as that's what I found in my TypeScript exceptions benchmark. However, it seems in C# creating exceptions is significantly faster than throwing them. And this is likely because C# exceptions copy the stack trace when they're thrown, so simply creating an exception does not incur this penalty. And largely creating that stack trace or taking a copy of it is one of the most heavyweight things that you can do, or that the exceptions do. And so skipping that penalty clearly has a pretty good impact on performance. And the last thing I want to highlight is that exceptions are for exceptional cases. My recommendation stands that throwing exceptions is good for exceptional cases, but a poor choice for anything else. They break control flow, they break the type system, and are very heavyweight. Here, 14 times slower and 2 to 3 times more costly in terms of memory. And so you should really use errors as values instead of throwing exceptions wherever possible. Okay, so those are the results of the benchmark, and then I'm just going to go into the benchmark code real fast in case you are curious about it. The main benchmark code is here in its entirety in the post, but if you want the full project files along with dozens of other example projects that I talked through here on the blog, you can join Hyminians to get access to the GitHub repo here. Your support does help me create more experiments and reports like this one and share them out for free. And so we'll take a quick look at the GitHub repo. And the first thing I want to show you is the result type that we're using. And we're using this abstract record thing to get basically a union in C#. And basically what we're saying is that we have a result type, and it can either be success or failure. Now this is like a very simple result type. I think true result type would have a few more things on it, like is okay or something, to help out with it. But this is basically the baseline result type that you might use. And then for the benchmark itself, we're using benchmark.net on .NET 9. We're going to be running this 1,000 times, each of these scenarios. And then we do the baseline, which is throwing exceptions. So we're just going to iterate over it 1,000 times. We're going to throw a new invalid operation exception, passing in a GUID as its error message, and then we'll just catch it. And then we're using sum here on the message length just to ensure that it looks like this is actually being used somewhere so that none of this stuff is removed or compiled away. We're doing the same thing for creating exceptions. We're creating that new invalid operation exception, just the only difference is that we're not throwing, we're just using the result directly. And then for using result types, it's the same thing except for creating the exception, we're just creating a new result. And then finally for GUIDs, we're basically doing the same thing, except we're just creating the GUID. If you're curious about other result types and other languages, I have examples for TypeScript and Python, and I'll probably put out a larger post talking through my C# results as well. Next. So exceptions are exceptional. If you expect an exception, it is now exceptional error here, aka not an exception. In those cases, you should use something else to model the error. Now, if you like this post, you might also like 5 reasons to stop throwing exceptions and what to do instead for a more robust, composable, and performant code base. You might also be interested in my TypeScript errors as values versus exceptions performance benchmarks. And finally, I've coded a C# library with Cloud Code, and here's 6 things I learned. So that's it for this video. Thanks for watching, and I'll see you in the next one.